Pleased to welcome Tadej Hakopian from Energy Vault, who is a program manager there. He'll be talking to us about information and visualization with digital twins for IoT. Welcome.
Thank you. Thanks, everyone. Getting started here. So yes, so we'll be talking about information and visualization, digital twins with IoT, and what that looks like. It's kind of like a little bit of a primer of what you can expect. So I'll get started. A little bit about me. I've worked a lot in technology in the physical environment, equipment, buildings, what have you, and trying to find a way to get the information out of the physical environment into this kind of digital format, either as a static, or I should say a discrete set, like an asset, like a 3D asset, or a dynamic set like reporting data. And it's always a challenge to get all the different parties together from different disciplines and different fields, and kind of have them speaking the same language about this new world of IoT and digital twins and how to make that real. So we'll talk a little bit about how all those pieces come to play. I've been through that rodeo a few times, and there's more rodeos to come since everything's kind of evolving field. And we'll start with the idea of like, what are digital twins? Because there's so many different definitions, I think. So I'll give you.
Hey, I'm so sorry to interrupt. You got to share your screen.
Yes, of course. My apologies. Share screen. One moment, everybody. I will share my screen right now. So let me back up here to the what are digital twins portion. There we go. So title. Let's move forward to what are digital twins. And the textbook definition is a digital representation of a physical object or system. You receive input from sensors gathering data from a real-world counterpart. You simulate the physical object in real time and produces outputs that could be used for simulations based on the physical object. Sounds great. And usually the idea is like, it's very powerful. You usually hear the word powerful with digital twins. But, at the end of the day, it's taking some hardware and making a digital representation of it as electrons. That's all it really is, but you can do a lot with it. As an example, this robot arm is being manipulated by a user, and that manipulation is being replicated as a twin in a virtual space, like I see in the big image. So that's usually pretty much what's happening with every digital twin. The information is being reported from hardware through a host to these visualization. That could be 100 different ways. The information visualization could happen, and you name it. In this case, we have both the visual animation and information referring to the actions of this arm in those numbers you see. So there's lots of use cases. There's a factory automation simulation, kind of like we saw in the last image, autonomous vehicle tracking, healthcare, using a device and monitoring battery. If you have a smartwatch like I do, that one is a digital twin of your heart rate, for example. That's reporting the very similar kind of concept. And structures and buildings, there's a ton of equipment in a given building, whether that's a building in the commercial space, industrial space, whatever, in your house, there's a ton of equipment running all the time in buildings. So the ingredients for a digital twin is IoT sensors, equipment, cloud, you need some kind of hosting platform, and data itself. So you bring these all together, and that's how you get the ingredients for a digital twin. And over the years, there's been a big scale up of these kind of services, cheaper hardware, easier to acquire cloud, and more ways to access data. So digital twins has really taken off. And there's a lot of benefits to it. Real-time look what's happening to your physical assets, so you don't have to guess or send somebody to look at some hardware, equipment, anything into a space. You could just monitor remotely. Maintenance and metrics being reported to one place. You don't have to sort through papers and hard copies for this sort of thing, depending on the industry you work in. If you're a facility manager in the built environment, it used to be just paper, like actual binders of content to check information, which was always out of date in that case. And you can scale the operations from small to large projects. It's just a matter of expanding your project scope, and predict outcomes based on historical data from device data, so you can figure out if there's a maintenance requirement or maintenance case to be made. So you don't have to wait until something breaks. You could just get the information in real time. At the same time, prepare if there's a lifetime of the equipment's coming due, or there's some kind of inefficiency in the product. And you're wondering, okay, that's great, but what's in it for the end user or owner. The benefits is more data for ROI in the equipment, easier to figure out information, and easier to get support if you're an equipment manufacturer. Using our IoT devices, you can push out easier support for your users, your end users. And with all this in mind, I want to talk about real quick data standards, our favorite subject. There are a lot of, just about any industry, there's a lot of different ways of explaining how something should be. The primary use case, schemas, digital twins and IoT is no different. There's a lot of different schemas and standards. So that's been a thing over the years. As you can see in this cartoon, usually what happens is you put one more into the bucket and people are even more confused. That's kind of what happened to digital twin and what they call Industry 4.0, things like that. They had this big set of digital twin consortiums and different standards released by different industry groups and different working groups that made sense for maybe a specific use case, like different kinds of devices, different kinds of machines, different kinds of whatever. And so it's been a little bit scattered. However, good news is you got the Digital Twin Consortium. This is a great reference to figure out the schema and terminology and definitions you could use to align everybody in a project scope. And the reason I bring this up is you might be working on, like, for example, the data side of things, DevOps side of things, cloud side of things. But if you're trying to actually implement something like this for a more comprehensive project, where you're bringing in people who may have no idea what you're talking about in any of these technology spaces, having this kind of reference, it's like, this is how it's done in the industry, goes a long way, because you can always send them, say, this is your document, this is your reference. So if you say, what's computational representation? You can say, where are, what's the function of the inputs and outputs? You can give them some kind of document like this, some digital twins consortium, which explains, what happens with computational needs in digital twins. So you could say the reference data goes through an algorithm based on the inputs that creates an output. Is this into the kernel of the actual operation? No, but it gives you a schema to follow, which is very valuable. We're trying to explain to people what it is you need to even get started. Same with stored representation. Like, what's structured information? It could be GIS, it could be IoT streams, databases, building information models, you name it. This is what that is. I always make a point about this because it's so critical to have standards and common language when you have so many different streams of, you have the guy who's been facility manager for 20 years who maintains your digital twin, the guy who understands the hardware portion of it very well, but not the software. You have the person who's, maybe the program manager on behalf of somebody, but doesn't understand the technology side. You can say, these are your common standards. So it's very helpful to have these kind of tools. And so digital twin is something I recommend. As long as you're not using Excel as a database, that will take you far. But it's always good to make sure you're all in alignment. I cannot emphasize enough alignment with everything. We'll talk more about that. So that's standards. And then we got tech stacks, which is even more fun. The ideal situation is you have something that kind of takes all the inputs and transforms it to all the outputs. That's not so easy in digital twin world. There's some better solutions over the years we'll talk about. Basically, you have a bazillion different kinds of inputs from different devices, and you have a bazillion different kinds of ways to report that. To simplify it, we have smart devices, which are the equipment, machines, monitoring, tracking, telemetry, phones, whatever you name it, that can then go reported to network gateways. Okay, this is the next step. You need some kind of Wi-Fi or Bluetooth or what have you to actually take the device data and transfer it to the middleware, which does the cloud storage, the network management, the hosting, and everything. That can then finally be used for applications, which is the meat of it. That's where people want to get the information and data from, eventually visualizations as well. So it's quite a different number of steps here, and this is just a basic schema of that. And there's a ton of different providers, whether it's the any kind of device side, graphic engines, cloud services like Azure, and you name it. There's a ton of different providers, and part of this issue is how do you bring them all together, because these might all come into play and say working in buildings or with a lot of data embedded into it, working with equipment manufacturers like Samsung, like Apple. They all have a ton of data into them, and then you have to find ways to connect all these different streams depending on your project. And of course, with that data, you have to find ways to present it, and you have a bazillion different options from different open source solutions like Python, like Pandas, but also things like cloud support, like Azure and AWS and all the others. So there's a lot of different ways to then take that data and work with it. So this has been the kind of the challenge over the years: is how do you take all these equipment information, work with all these different suppliers and vendors, put it together, and then also find a way to transform that data. But to keep it simple, all we're going to focus on is sensors in the real world, some kind of model representation, some kind of digital model representation, and hosting. The servers that connect the sensors and models to other endpoints. And with hosting, what's great is you have Azure Digital IoT. And what's really great about that is it does what you want it to do. It takes a lot of the sources, different sources of the information, and transfers them to different handlers, for example, in this diagram. But you can take it further, and just like the diagram I showed you prior, it has a full spectrum solution with Azure Cosmos and IoT. So between the hardware, the things, you can then transfer to a gateway hub, and then from there, it goes to the hosting and data platforms, which from there you can create applications, just like we saw earlier in this slide series. So it's all there, and I have a link to the bottom there if you want to learn more. So it's great that we can see these kind of integrations and meshes of data instead of having to kind of jerry-rig it ourselves. It's becoming a lot more consolidated. So there's a lot of opportunity to create these kind of integrated workflows with these backbones, like Azure. And we'll talk about next about hardware, to get a sense of what the hardware environment looks like after we talk about hosting. So usually we have these kind of situations in hardware. You have the built environment, and you have the data you want to get out of it, information. And so you have to put them together into some kind of application. But usually you have to start first with the actual equipment, and the equipment is, in this example, an apartment. It could be your appliances, your phones, your keys, your security monitors, you name it. There's a ton of equipment in the average apartment that is already enabled for gateways for IoT and smart homes. And that could be as simple as well as a custom-made Arduino board that can use open source tools to connect the information to the gateways. So there's 100 different ways you can connect hardware to the built environment. In this example, this is just a little board that you can put onto the back of a wall. In this case, they're using these for modular construction for homeless projects in homeless housing projects in Los Angeles. There's one example what you can do with IoT devices. You can make 100 of these very quickly, pin them onto a board, and then they'll just report data about whatever you need to report data on, whether it's occupancy sensors, heat, equipment. It's all there. So this is what the actual hardware can look like in the built environment that might be all around you in a given facility that you're sitting in, maybe right now. And it could be huge. This is the deliverable plant by Ford that uses these huge 3D assets these huge assets in 3D of industrial equipment. And that they mapped all this out to their own digital twin. This is a 3D example and visualization of that. So they can monitor it remotely without having to necessarily be there. They know what everything's in there, what it looks like, the information therein. So it could be from a tiny scale to a huge scale. It's all depending on the need of the project. It's all doable. So with all that in mind, we talk about visualizations. And what's really great about visualizations is it's very intuitive. Visualizations has a lot of ease of access to the average person, whereas the backend stuff of the hosting and the hardware might be for specialists. Anybody can get a lot out of visual tools and how they can see the environment in VR or into a application. So in this example, this is kind of a little comic here, but people love putting on those goggles, just seeing the world for themselves, stepping into it. And there's a lot of applications you could use. So you can imagine taking all that data we got, all those 3D assets that we have, and connecting it to an environment that you can easily look at in 3D. So what does it look like? It could look like 3D models, just basic geometry on your screen. It could look like charts, just information charts. That's another way to visualize your environment from a digital twin. It could be VR, immersive. And it could be maps, like laying out the map and environment to see where everything is. So we'll look at some examples of all that. In this case, we have this example of using a 3D space of a building and checking data over a series of time in 3D. This is very intuitive. People can see their building, the layout changes over time, and they can track the progress. I talk about the average user at the end of the day. This is the kind of thing that all the applications come together could benefit from is this kind of easy to use UI. And it can get even more immersive. You can do something like in this example, using the same tool. This is a Autodesk tool that does 3D visualization. In this case, we're seeing temperature with the highs in yellow, lows in blue in this office space. This is a user can navigate this space, look at what's going on very easily. These are all based on actual telemetry sensors of data in this space. So if anybody's curious what's going on in the office, let's say the office administrator is trying to figure out what the temperature is, people are comfortable in the office, they can pull something like this up and look around. So this is the benefit of the visualization. You don't have to be a wizard at any of the technology or backend. It's all just there, easy to see, clean, nice little heat map we have here. So this is very intuitive and people can navigate it very quickly. And then you also talk about the VR space, how people can do something like this, which is using equipment in real time that is then tied together with a VR headset, so people can be trained remotely on hardware equipment that might be somewhere else. That way, you can train people to use just about anything, anywhere, with some headsets and some connection to the actual equipment. They can click through it. They can look at all the handles and nozzles and all that stuff. So this is a case of real-time interaction. It's not static. It's like, it's happening. So this is another example of how that digital twin can be useful in applications of training. And that could be including surgery, for example, doing some surgery on a dummy remotely if you can't be there in person, or at least monitoring the surgery in real time if you can't be there. And we talk about, maps and layouts. In this case, it's a simple map of a floor plan of a building. And we're getting just some occupancy data. Looking at this solution here, we should look at a floor plan, see the kind of information, whether it's humidity, temperature, comfort zone, really quickly checking it out. In this case, it's a lot more bread and butter example, easy to read for anybody who knows how to read a floor plan, and get a lot of data out of it, again, in real time. Look at it in your app based on real-time updates. Or inventory. In this case, this solution right here uses a inventory of all the 3D assets already programmed. This is an example of how you can use what they call a building information model, a BIM model, to say, okay, like I already created your entire asset of, say, an office building, or in this case, a hospital, into a model. And in that model, you have every single asset in your hospital: beds, every kind of door, every kind of chair, sofas, you name it. It's all in the project. So if it's already designed like this, and it's already in this discrete database of a BIM model, I can then give you an inventory of all the equipment you'll ever have in this building, at least on the turnkey basis. And then you can hook it up into an inventory tracking system, again, through a digital twin, that can then keep catalogs of all the equipment. And you can sort it out nicely into a given type of equipment, like doors, chairs, you name it, so it's easy to track. And you can tag the warranty information and everything in here. And over time, you can update it with changes, new purchases, new orders. This is another way to describe that data for somebody in that world of maintaining space. You can even go full bore to the game space and use something like the Unreal Engine paired with, say, an Azure backend, and using different kinds of 3D assets, whether it's from, say, 3ds Max, BIM models, you name it, and create a real world environment. This is a project from China showing how you can use Unreal Engine with all these different tools, the 3D world, the sensors and the hardware and the backend hosting, to create an immersive world that somebody can see what their industrial equipment looks like. It can go anywhere from very straightforward solutions that are provided to you by a vendor to these customized kind of solutions where you can build them ground up. And you can go from the campus building scale to a huge city scale. This is Helsinki. They're doing a digital twin project of their entire city, starting with some of their business neighborhoods. And in this case, this is the urban scale. This is the geographic information systems paired with the city databases, paired with information from different sensors that they can report. Much bigger scale, much more comprehensive data, because you can go into the buildings, you can go to the streets, you can go to geography, the weather, it's all there. So you can get really big with digital twins. It's all a matter of how you develop it. And it's, again, a matter of how you structure it so people can work with you on these bigger projects. But it could start from a very small premise, like a room in a building, to something this big, to give you a sense of what's possible on the visualization scope. So talk a little about planning with the last couple of minutes. Who pays for all this? The owner of the project pays for all this. It's not necessarily inexpensive. It just depends on how ambitious you are. Okay, so the business case has to be justified as proposal. Is this a valid proposal to get these kind of IoT, digital twin services included the way we've talked about it? Can you set up a pilot project so that you could have a low cost or no cost way of testing out? Maybe it's the right solution, whether it's for equipment, vehicles, building, you name it. Is it the right solution? Let's do a pilot project, test it out, test the waters, see what works. Maybe your client would like this solution to be implemented. What's the ROI? Consider what the potential savings are when you have a way to report real-time information about equipment and sensors that could tell you if there's something that's going to be breaking down, if something needs maintenance, or just tracking inventory or tracking people's comfort in the space or their experience using some equipment. What is the ROI? What's the amount of time you save doing that? What's the potential time and equipment savings? And look for opportunities. Maybe you have to ask around. Maybe you have to prod a few people and see, hey, what can we do here? Is there an option to use a hosting solution in this project, use some equipment, whether it's Arduino boards or something a lot more robust? Look for the options and opportunities available to you. And always better to, when it comes to adoption, start early in these kind of cases. Again, this is a learning curve. You're never going to figure out the first time. It's going to be a lot of stakeholders over a long period of time to make these kind of digital twin projects possible. So you want to avoid trying to catch up when this becomes very commonplace. I've been in situations where technology in a given industry, let's say healthcare is our standard, kind of like a whipping boy for laggards, might be taking a while to adopt, but once they adopt it, they really want it, and it goes from 0 to 60 quick. Instead of they give you the same old kind of expectations of what they want for a project scope that you might have worked on with these kind of clients and owners, they get religion really quickly, and they're like, you know what, we want this now, and you're like, oh wow, and you have to jump on it. So try to be as progressive as possible, so you don't end up in a curve of like, oh, we've never done this before, never to scale. Always try to be working with the early adoption curve. Look for those opportunities so you don't end up being a laggard where it's challenging to adjust, where you have these huge project requirements and you're not sure where to start because there's so many different stakeholders depending on who you're working with. And just kind of a quick cycle on the project team setup. You want to assess the circumstances of the project, plan it out, document what's needed, train people, and this could be executives, VPs of whoever you're working with, whether they're procurement side, operations, even your own technology team internally. It doesn't hurt to train it because I guarantee you nobody's going to know every facet of how a digital twin works in one way or another. Maybe very savvy on the cloud side of things, but not so much on equipment or operations. Training goes a long way. It could be a simple, primer. Common data environment, CDE, what is that going to look like? Is it going to be a 0? Is it going to be something else? Figure out what that's going to look like. And then get the cloud host, analyze the data, study the trends from your data, your historical information, get valuable insights, update your operations, and repeat forever. Easy. And I would love to show you an example from work, but I can't. But suffice to say, we are using some digital twin solutions ourselves. We are using a 0, and it kind of looks like something like this on the ontology models. And so we're plugging away to get some work done ourselves to connect our devices to a cloud host, to do an analysis, to eventually get some useful information, whether it's information for operations, purchasing, logistics, you name it. This is the kind of things we're looking at ourselves. And what's great about Zero is they give you a full platform to do just about everything I've just talked about. And I think it's the way things are trending over the coming years and months, or I should say years. But it's accelerating. So look at these solutions. Look at what kind of needs you want. This talk is emphasizing the big picture things because, again, you're never going to know every single part of this. So it's great to have a strategy, have a roadmap, have a plan, have some ideas out there of what you want to achieve, what you could be solving problems for, because this is a huge growing demand for digital twins in the whole built world. And to get started, if you want to figure out how to plan for your digital twins in 4 easy steps, know what you want, what kind of things you care about, look for the opportunities, what do you want to achieve, plan it out, figure out what you want to do and how to connect it together, figure out your gaps, and adjust your operations in case they go off course, because they usually do go off course. and figure out what you want to achieve. Do you want building performance or equipment performance? Do you want user feedback about some equipment they're using? Do you want to do more automation and less service for equipment? And bring it all together. We're creating connections to physical environments, get live updates for physical equipment, have a place to store the data, analyze the data, update the equipment digital assets, repeat forever, just like the real world. The ride never ends. And takeaways, I'll breeze through these, what we talked about. In a nutshell, physical assets connect to digital assets via digital twins, standardizing bodies providing a common ground for digital twin strategy. There are lots of different options. Figure out the one that best fits you, test them out, and find opportunities to try out digital twins. Here are some references. Also will be in the video notes for this event. And thank you so much for your time here. It was a pleasure speaking as your Cosmos DB. I hope you all got something out of this talk. Please contact me if you have any questions. I don't think we have time for Q&A, but I'm always happy to talk with anybody about these kind of topics.
Thank you, Tade. Thanks for the great explanation, introduction to digital twins and IoT. It's really awesome to see just even more broadly how far technology is progressing, and just seeing that robot arm in real life versus the thing it's wild.
Yeah, same here. I had a really great thoughts on that. You mentioned like that there was like a trifecta of an IoT like sensor that emits some data, and then you need the store or some like database storage. In this case, you guys are using like Cosmos DB is what I heard at the last couple of minutes. How is Cosmos DB doing in terms of like latencies, and I know throughput and write heavy workloads, that kind of thing?
Well, currently we're at the early stages, kind of like we're at our own little pilot program. So it's a very base level kind of latency, but we're trying to see if we can scale it up to like thousands of updates a second for some of the equipment we're testing out. So it's we're starting out at a very basic point. That whole earlier stage I was referring to, where we're assessing and trying to bring things together and figure out stakeholders and exactly what we need, and then we're with the Azure tools we're using, we're trying to lay that groundwork so that we can aggressively push that kind of reporting. So to much more intense. So we feel pretty confident with the Azure tools we're using, and it's been working out both ways. It's been working out pretty well, and we're pretty excited about the things Cosmos and digital twins and IoTs being put together with Azure. It's one of the reasons we are using Azure for some of our project operations. So it definitely scales up pretty nicely in the long term, because depending on what you're doing, it can be some intense data reporting that might not be for everybody, but it's something we're looking at.
Thank you so much, Tade, and thanks for joining us on Cosmos Conf today.